Been asked to do a bit of a run around on my Composite-Arf Pitts S12. It's built by Composite-Arf, as I've just said. It's 2.7 metres. It's powered by a DA200 4-cylinder with KS canisters. Has BLS 152 brushless servos throughout, and has a power box to take care of all of that. What I'll do is I'll take the bonnet off and give you a look underneath, and we'll have a look inside and give you an idea of how I set it all out. I'll get Mark to come on over and we'll have a look inside the canopy. Under here is fairly straightforward, as you can see. It's got a 64-ounce fuel tank. It's got a Futaba fast system through it with a Powerbox Competition. Now I use a Powerbox Competition, it's a 12-channel one. I wanted to run all the aileron servos independently so I can play around with some differential and a few other odds and ends without getting too complicated by making adjustments through the Powerbox. This is a very simple setup. It also tells me milliamp hours used out of each pack, as well as current voltage, and gives me servo adjustment on 4 channels. Nice piece of kit, I really like it a lot. It's got Fromco 5200 milliamp packs, running 2 of those, and a Fromco lithium phosphate A123 pack for the ignition, which is running through a Rhino kill switch. Now I'm only running 2 BLS 152s on the rudder on a closed loop system, so that's got a redundancy system. If I lose a servo, I still have a operational servo. They're not bound to each other. They both work in unison, but the closed loop system gives them some kind of redundancy. These are 31 kilo servos, got more than enough power to operate this little beast, and I highly recommend them. They're a really good servo. Got an Extreme Flight Pilot in there. He's nice and light, doesn't take up too much room. A few things are a little bit different on this one over your regular S12 that Composite do. Composite rely on running 2 elevator servos at the rear with a long push rod. I've changed mine slightly because I have a 200 in it. I've got the added advantage of a little bit of weight at the front there. So I've changed all of that, and I'll show you over the stabs later on as we go along. You can see where I've cut in the BLS 152 Futabas. The problem was you can't quite get these fully inside the stabilizer. There's not enough room. I have built in across here some sub ribs so that the servo can screw into that. A little bit of drawing up just to make sure everything is going to go in nice and kosher, but it's a direct drive. Really nice. One servo takes care of it. It's quite a big surface. If you ever intend to do this, make sure you get a good quality servo with a lot of power. These, as I said before, are 31 kilos each and operating on a 1-inch arm, so they're quite short. If you're intending to do enormous 3D and you want enormous deflections, you may want to look at something slightly different, but in my case, where I'm running a pretty good deflection, that's more than enough for me. The plane's quite active at that. 1-inch arm is more than suitable. This is the top right hand wing. As you can see, they're all pre-hinged. Composite make a live hinge down here, so it's all hinged from the top, same as any other composite. Underneath you see provision for 2 servos and their servo bays. As I'm running the BLS 152 31 kilo servos, I only require 1. It's not an enormous surface, and I'm running 1.25 arms, which gives me a reasonable amount of deflection. It makes it roll quite fast actually. I'm running Seacraft arms on this, nice alloy ones with 3mm ball links, and I'm using a clever system at this end, which is pushed through the aluminium here. It's absolutely slot free, and it's a very powerful system. It works quite well. You could run this with 2 servos easily without too much trouble. You could get away with 2 15 kilo servos, no question at all. This is a little bit simpler, which is why I opted for it. Off at the business end of things, it's as you can see, the DA200 is a 4-cylinder. This is one of the magnesium versions. It's got the magnesium crankcases with milled down cylinders, so they get quite a bit off weight off a standard 200. This one weighed in at just over 4.2 kilos, 750 grams lighter than the standard DA200s, which is quite significant. As you can see, I've got 4 KS86 canisters fitted throughout. It was a little bit difficult to fit a 2-in-1 system in this aircraft because of the undercarriage plate. It was extremely difficult to get the 2-in-1s to go back up over the top, so we opted for 4, which required us to open up the side of the the engine dome. Took a little bit of measuring, a little bit of cutting and shutting with the header system, but the header's all fitted nicely into place, as you can see, and all seems to work quite well. The baffling on a 4-cylinder is quite different to a twin. It's baffled through the horizontal plane, so all the air going in through the top of the canopy must come back through the cylinder fins. So any air coming from the top is coming through the fins, aiding with the cooling. Carburetors are linked here with a titanium push rod, so they both work together. Because the carburetor on these have a return spring on them, I'm using a soft loop system, so that it's like a pull cable basically that pulls on the carburetor and returns under its own power from the spring. This works extremely well and is vice free. You get no vibration back to your servos. As I said before, I'm running a Rhino kill switch on both ignitions on this one, and I'm also running 2 clunk lines on this, so that each carburetor is fed independently of each other through the same tank. On the Pitts that's where all the venting takes care of. As you can see, I've got quite a lot of aluminium louvers on here. The reason I went for the louvers, most of you probably know that when you've got a louver which has got a lip at the front of it, it helps draw the air out. When you've got a straight hole just cut across the bottom there, the air rushing across it can help, can generally stop the air from venting out as clean as it should. Whereas with all these little louvers here and these little lips here, cause the air to flow down and away, which actually draws the air out a little quicker. There's quite a few on this. There's quite a bit to be cooled in here when you consider you've got the 4-cylinder in there, which is essentially 2100. So you're trying to cool down a lot of cylinders in there, and as you can see, it's sufficiently vented. And from the inside, there's quite a few holes there.